Hi and welcome to this video about integrity levels. I mentioned integrity levels briefly in the last video when I talked about elevation or user account control elevation. So now I want to discuss integrity levels in some detail. So what is that all about? So here's an example of how access checks are typically done in Windows. What happens if we have, say, a process running under some user named Alice, and Alice is member of a group called writers, maybe some other groups, but that's the group we care about here. And Alice wants to open a handle to a kernel object, let's say a process, for example, maybe some notepad process running on the system. And Alice wants to get this particular access mask, this particular kind of power to the returned handle for this process, which in this case are going to be a VM write and query information. So the caller here, the process running under Alice, wants to get both of these access capabilities to the process. And so the process, being a kernel object, is protected using something called a security descriptor, which maybe I'll discuss in more detail in a separate video. And a security descriptor has two main ingredients. One of them is the owner of the object, which I'm not going to cover here. And the second thing is how this object is protected using something called the discretionary access control list, or DACL for short. And the DACL is comprised of multiple access control entries, or ACEs, each one indicating, using three parameters, something about the object. So we have allow or deny, the actual user or group that this applies to, and the actual setting, the actual access that it is referring to. And so the way the security system works by default is just by traversing the DACL from start to finish until we get a definitive answer. If we traverse the entire list and there's no definitive answer, the answer is going to be access denied. So in this little example, let's start with the first entry, which says that Alice is allowed to perform query information. This is one of the things that Alice actually wants, so that is good. So it's being marked as retrieved, so possible to get, but it's not the full access mask Alice needs, so it's not a definitive result. We have to move on. The second DACL here says that everyone is denied performing process suspend resume. However, in this case, the caller is not asking for process suspend resume, so it doesn't mean anything. So again, we move to the next ACE. And this ACE says that the writers group are allowed to get a process VM write access mask. And since Alice is part of the writers group, this means that Alice is allowed to get process VM write. And since this completes the entire access mask the caller wanted, we get the final result as access allowed. So a proper handle will be returned to the caller with these particular two access mask bits. So that's all good and well, but there's one piece here that is missing. And the thing is that what happens if Alice's process is running with admin privileges or not? What about the process she's trying to open? Maybe that process is running with admin privileges or not. So shouldn't that matter in some way? In the original way Windows works, this doesn't really matter because there was no such concept of user access control or user account control before Windows Vista. But starting with Vista, since we have that, we probably think that it makes sense that maybe the target process we're trying to open, it matters if it's running with standard user rights or administrative rights. Maybe if Alice's process here is running with standard user rights and tries to open this powerful handle to this process that may be running with administrative rights, maybe that shouldn't really work. But in the original security system, this doesn't get checked. And so it just checks the DACL. So in this case, in this little example, Alice would be able to open a handle to this process regardless of whether this process is running with admin privileges or not, which might seem a bit strange, and perhaps we don't really want that to work in this way. So this is where integrity levels come in. So integrity levels were introduced in Vista along with user account control because now we need to have at the very least a distinction between processes running as admin and process running without admin rights. They're still running under the same user, like Alice, for example, or Bob or whoever, but the fact that they're running elevated or not, meaning their token is powerful or not so powerful, should matter in some way. And so the idea here is that all kernel objects can have an integrity level. And as we'll see, there are a bunch of integrity levels defined. We'll see that in the next couple of slides. And medium is the default for compatibility reasons. And so any kernel object, not just processes, it's also about files and mutex sets and semaphores. Any kind of kernel object really has an integrity level, which by default is medium. And the reason is that because standard users run with medium integrity level as well in terms of processes, then this kind of doesn't matter. So the usual access checks apply like they were many years ago and were all the time. And for processes, by the way, integrity levels, the actual integrity level is stored in the primary token. So I'll try to piece all these things together very soon, just bear with me. So these are the standard integrity levels that are defined. They're represented as seeds, and because that's something you can specify within a DACL, for example, and this is where integrity levels typically are stored for other kernel objects, which are not processes. For process, it's actually stored in the primary access token. And so they all start with 116. 16 is the authority ID, so to speak, and then another number which just indicates the level itself. And so the number can be anything really. It doesn't have to be one of the numbers you see here in the table, but the numbers in the table are defined explicitly with defines in the Windows headers, and they're kind of known. So you can see that 1000 is described as low, 0 is untrusted, and then we have medium, which is 2000 hex, and then there's also medium plus and high and system. And I'll describe how they're assigned very soon. So these are the numbers that are properly defined, but you can technically have a number like 2500 hex. That's also is a valid value here, because the seeds at the end of the day, the integrity levels are compared just by comparing these numbers. So the higher the number, the higher the integrity level is. So where can you see these integrity levels? I'll describe that momentarily. So the important point here is in the last entry here that says integrity levels are examined before access control, and that's the important point. So the access control we've seen in the first slide is the second thing that is checked only if integrity level check is okay, that is allowed to proceed. So here are the basic rules. When a process is running with standard user rights, it gets an integrity level of medium. If it's running with administrator rights, it gets integrity level of high. All the services running one of the three special service accounts like local system, network service, and local service run integrity level of system, which is higher than that. And the default rule is for integrity levels that is no write up, which means that if I try to open a handle to an object that has a higher integrity level than my process, then it will only work if I will not ask for right kind of access. And the right kind of access is what generic write actually means for that particular kind of object. For processes, in fact, there's an additional rule, well, not an additional, but slightly different rule that says no write up and no read up, which means that a process with a lower integrity level than the process that it tries to access with even a read operation, that will not work, regardless of any DACLs or security descriptors. It's the first thing that's being checked. And so if integrity levels are not properly set, then it will not work, and the security descriptor is not really being looked at all. So let's take a look at what that actually means in a few examples. First, how can we see integrity levels of processes? So the simplest way to do that is to go to Process Explorer. We can right click and select the columns, and there's a column here called integrity level. So we can just select that, and it will show us integrity levels for all processes. And let me just grab it here and move it closer to the center here. You can see we have medium, we have system for various services, we have high for processes running with administrator rights. There's also something called low, which I also mentioned, but there's another thing called app container. An app container is really the same as low. It just means that this is something that is used by UWP processes like calculator, but from integrity level perspective, it's the same as low. And you can even find something called untrusted, which is the lowest of them all. In fact, we can just sort this thing by integrity level in descending or ascending order and see what's going on. So you can see we have system integrity level for all the various system processes and services. And then at some point we might have a few high, those running with admin privileges, like say Task Manager here that is running here, and also Process Explorer is running with high integrity level because it is running with admin privileges. And then we get the medium processes, those that run with standard user rights, which is like the normal kind of thing that happens. And at some point we might even find low integrity level here, like you can see Slack here is running with low integrity level. And of course we have app container for UWP processes, which are always running with low integrity level as well. And even lower than that, we can see even untrusted. So untrusted is typically used by browsers. Also low is used by browsers as well, because when you download a file from the internet, from some kind of browser, the integrity level of the file you download is going to be the same as the process integrity level. So it's going to be untrusted or low. That will not allow you to do anything, anything like problematic, even if you run it. Even if you run it, it's going to run with low integrity level, and then it will not be able to access even simple things like the My Documents folder, which I'll demonstrate momentarily. So it can't even be some kind of ransomware that tries to encrypt your files. It wouldn't be able to do that. So you can see these integrity levels right here in Process Explorer for processes. For other kinds of objects, you need to use different tools, which I'm not going to describe in this video. So that's one thing. And let's see what that looks like when we try to test the same idea that we've seen in the access check slides. So the first thing I'm going to do, I'm going to launch a Notepad process. Here's a Notepad process. And since I've launched it using just the shell, that is Explorer, or just using the run button, if we look at Process Explorer, we'll see that this Notepad process, let's just sort by name. Here's the Notepad process. It has a medium integrity level. So I want to launch another process of the same kind of Notepad running under my user, but with admin privileges. So I'm going to just go to the taskbar here and press Ctrl Shift and click. That's the simplest way to elevate to run another process with the same executable. So I'm just going to do that. Of course, you can just go to Explorer and use right-click Run as Administrator, as we've described in the last video. So here's another Notepad here. So this second Notepad, you can see it right here, it is running with high integrity level. That's what we have here. They're both running under the same user. That's the same user, that's me. If I double click, by the way, and go to the security tab, which we know describes the token, we'll see that the integrity level is right here, is part of the properties, or a group, if you will, that is part of the token. You can see it says medium mandatory level. That's basically saying that's the medium integrity level. If I do the same thing with the other Notepad, you can see it says this is the high integrity level here. And we've seen already that it has many more privileges because this is running as administrator. It has many more privileges and powers. So that's something we already kind of know. But let's see what we can do with code here. Let's say I want to open a process, a handle to one of these Notepad processes. So first, let's start with one of those, the one that runs with medium integrity level. It has a process ID let's get it here. So we have 64184. 64184. What I want to do, I'm going to get a handle to this process. I'm going to ask for something simple like process query information. Process query information is part of the idea of a read kind of access to the process. I want to get some important information about the process. So here's when I'm going to specify the process ID. So let's see if that works. I'm going to just put a simple breakpoint here, press F5 and run this thing. So here goes, it's being built and launched, hopefully. So here goes, we get to the breakpoint and I'm going to do F10 and this works. Sorry, this fails for some mysterious reason, and that might be because I've made a mistake in my process ID. That's 64184. That's my bad. Sticky fingers, I guess. So let's try it again. And now it works. So we do have a handle, everything seems to work as expected. We're all kind of good, everything is fine. We get an appropriate handle, no problems there. But now let's try the same trick with the second notepad, the one that is running elevated with a high integrity level. So that's 67500. Let's change that to 67500. Let's try it again. And now if I try to open that up, I get a zero handle. This fails. If I look at the error, here we can see it's access denied. So even though I'm running as the same user, in fact, the process here, this test process, so to speak, is running with the same user Pavel. So here's the test process running as me. But since I have a medium integrity level, I'm trying to open a handle to a process with a high integrity level. I can't do that. I can't do that with a read kind of access. This is not allowed. That's the rule no read up, which is the default rule for processes. If I do something slightly different using something like query limited information, which is a different kind of access, it's a weaker access and it's part of a generic execute kind of group, then we'll see that this kind of thing does work. So I do get an appropriate handle here which I can use, but of course it is limited in what it can do because it only has limited information or limited powers towards the process. So this is allowed because it's not a read operation, it's just an execute operation as it's defined. And where do I get these definitions, by the way? You can look that up using the Object Explorer tool that we've seen multiple times. One of the things we can see here is the generic read, generic write, and generic execute constants here, and this is exactly what is being checked. So when I'm saying no write up, I mean whatever write means for that kind of object using these generic write constants. For generic read, if we take this further here, we can see that it is about VM read and query information. So process query information is part of read. On the other hand, for execute, which is always allowed by default, it's query limited information as part of that. It's something we can do. We can also have synchronize, which is the ability to wait for the process to become signaled, to terminate basically. So this is something we can get for processes with a higher integrity level. That's allowed. So this is what that actually means. And although I've given demonstration here for processes, it means basically the same thing for other kinds of objects, even though the default rule there is no write up and not just no write up and no read up. So processes have a default different rule, so to speak. If I go ahead and relaunch Visual Studio here as admin, just to prove the point. So when I launch Visual Studio as admin, I have the same integrity level as the Notepad process I'm trying to access. The Notepad process has a high integrity level, and the process that I'm accessing from my Visual Studio process here, or the test process that's also going to run with a high integrity level, are now the same. So if I go back to trying to get the query information, which I previously failed, this time it should work for me. It should work for me because we have the same integrity level. In this case, the actual DACL is checked. And since we're running with the same user, the default DACL is going to say that's fine. You can access the process in any way you see fit. That's the default protection processes get. So if we try this, we can see that it indeed works. So we have a proper handle here that should work as we expect. So we have the handle here, even though Visual Studio here is slightly sluggish here, because that ReSharper C++ extension, I'm still contemplating whether to keep it or not. Anyway, we can see it's a valid handle here as we expect. So again, going back to Process Explorer, we can see that our test application here now, which is the one we're using, is running with high integrity level. That's why it works, because it has the same integrity level as the target object we're accessing. The last thing I want to demonstrate, just to show you the power of integrity levels and to prove that all kernel objects by default have a medium integrity level, is I can launch a process with low integrity level. And I'm going to demonstrate how to do that in code in a future video, but for now I'm going to use an existing tool, which is going to be PsExec. So PsExec is a tool from sysinternals that has lots of powers. One of its powers, which is kind of maybe a sub power, if you will, is to launch something with low integrity level for experimentation purposes. So I'm going to use PsExec-L, which is the one that is needed for low integrity level access. I'm going to run Notepad here. So Notepad runs now with low integrity level. To prove that, we can go back to Process Explorer, look up this Notepad. You can see the integrity level now is low. So it's lower than medium, it is low. And now what I'm going to do, I'm going to try to write something and save it. So I'm going to try to save it in my documents folder. That's where I want to save it. So here I'm going to save it as a low.txt. And you'll notice I get this strange error saying you don't have permissions to save in this location. And would you like to save in the documents folder instead? But this is the documents folder. And the thing is that the documents folder has an integrity level of medium, and since the default rule is no write up, which means I cannot write to a higher integrity level object, writing to the file system is a write operation, and since Notepad is running with low integrity level, it cannot perform this write operation. And so the error message is kind of silly because it assumes that I'm trying to write to some system location like system32 or something like that, where in fact does have a high integrity level, but this is not the case here. Documents has a medium integrity level, but still doesn't work because currently the process writing is running with low integrity level. And that's why browsers try to run with low integrity level, because if you download the file like an executable, and even if you run it, it will run with low integrity level, which means that it can't do certain damage, even can't write to your My Documents. So it can't, for example, encrypt your files like ransomware would try to do. So that's the basics of integrity level. I hope it makes sense, and you can continue exploring that by using the various tools and some other tools you'll find online or in the official Microsoft documentation.